So, okay, in the last class we have discussed about the interfacing of 7 segment display to 8086. We have discussed about only a single digit. Okay. If you want a multiple digit displays is to be connected to 8086, then we need many 7447s. Okay. So, in order to avoid that, we can time multiplex this displays and we can use only one 7447. How you can time multiplex this displays? Now I am going to discuss multiplexing of 7 segment displays. Multiplexed 7 segment display interface. Let us assume that we want to connect 8 7 segment displays. Okay. So, starting with here on 7 segment display, this will be having A, B, C, D, E, F, G, H, and there will be one common signal also. This is common signal and this is A, B, C, D, E, F, G. Let us assume that all displays are common anode type. Now we have one more display. A, B, C, D, E, F, G and common signal. Like that, suppose we have up to 8 displays. And this is common signal. Now, instead of using 8 7447s, I will use only one 7447 and I will connect to all the 8 displays. Let us assume that this is display 1. Display 2, display 8. Okay. So, I will take one 7447 which is BC to 7 segment decoder. This is 7447 which is called BCD to 7 segment decoder. The input BCD value will be given by the port this is BCD input. And outputs will be 7 segments A, B, C, goes on up to this. A to A, you have to connect through 150 ohm resistor. As we have discussed in the last class, A we have to connect to A, B to B, C to C, and so on. So these are all 150 ohm resistors which are called current limiting resistors. This is segment A, B, C, D, E, F, G. Okay. This I will connect to the port 8255 port. So I will take here 8255. See 8255. I will connect to one of the ports. Let us assume that this is port B. So I am going to connect to this to PB 0, PB1, PB2, PB3, port B, whose address is FDH, and inside this there is a control word register whose address is FFH. And then we have port A, whose address is FCH. Now we have to connect this port A to the common signals of this 8 7 segment displays. Okay. So I will connect this to PA0, PA1, PA2 and so on. I will remove this and I will write at the top of this. So this common signal through transistors. Okay. We will take first this signal. I will connect through transistor to similarly you connect this so we are taking PNP transistors. All these emitters we are going to connect to plus 5 volt supply. And base is connected through ports. This will be connected to port A and this will be connected to port B. PA0, then PA1 and so on. So this is PA0, this is PA1 and this is PA7. Totally I am connecting 8 7 segment displays. Okay. So this emitters we have connected to common plus 5 volt supply, and here we are going to connect 1 kilo ohm resistors. So this is the complete setup. So where we can connect 8 7 segment displays to one single 7447. Now we are going to connect A's of all these to common A. A will be connected to A of all these segments, A of this, B to B, C to C, and so on. So on up to G to G. So single 7447 is going to control 8 7 segment displays, display 1 to display 8. Okay. Now the procedure here is, what we are going to do is, first I will send a logic 0 on PA naught and the remaining I will make as 1. I will send a logic 0 here, the remaining all bits will be 1. Okay. So in port A we are going to send PA7, PA6, PA4, PA3, PA2, PA1 and PA0. I will send all ones except P0. PA7, PA6, PA5, PA4, PA3, PA2, PA1 and PA0. Then what happens is, here because this is PNP transistor, if I apply 0 here, this particular PNP transistor will be on. So it will act as short circuit, this 5 volts will be appeared here. So because this is common anode type, to activate this particular display, a 5 volts signal has to be applied to the common signal. Okay. So here only this particular the last display will receive logic 0, so that this will be on and the remaining all will be off, because we are going to send logic 1. So logic 1 means this will act as open circuit. Okay. Now the last digit display 1 will be selected. Suppose if I want to display, say the same digit 1, 2, and display 1 I want to display 1 and display 2, 2, display 3, 4, 5, 6, 7, 8. So I want to display simultaneously 8, 7, 6, 5, 4, 3, 2, 1 on these 8 7 segment displays. So I want to display here 1, means we can send here 0, 0, 0, 1, 0, 0, 0, 1, this is BCD correspond to 1. So it will generate the corresponding code to display the 1, which is BC will be 1, 1. So this will be, because this is common anode type, 0 will lit the corresponding this. So this will be 1, 0, 0, 1, 1, 1, 1. Of course this pattern is common to all the 7 segment displays, but for the first 7 segment displays, the common point is connected to 0, because of that they will be off. So only here the common point is connected to 0, this is 1. Only this point will be connected to 1, this all remaining will be connected to 0. So because of that, only this 1 will be displayed on first common cathode type display. Now you allow some time, after that you send 0 on all the signals, means this also you make as 0, so that all will be off. Then you select this 0 you replace with 1 and you send a 2 on, code correspond to 2 on this display, again you call some delay. So like that you proceed and you go up to this digit 8 here. Then after this 8 again you come back here and you display 1 here and you repeat this process. Okay. So this is for revision of this process. Actually what happens is here, so you keep this 1 for 2 milliseconds. After 2 milliseconds, so this will be displays 1 and after 2 milliseconds you display 2 on this. After another 2 milliseconds you display 3 on the third display. So, like that another 2 milliseconds you display 8 on the 8th display. After this again you go back to this one. So, what is the time taken to come to same one starting with this one? So, what is the time taken to come back to again 1 is, this is 2 plus 2 plus 2 plus 2, 8 into 2 milliseconds, which is equal to 16 milliseconds. After 16 milliseconds again you are displaying 1 here, 2 here, 3 here and so on up to 8 here. Okay. So, this 16 milliseconds, the refresh rate, which is called refresh rate, the refresh rate is high enough. The refresh rate of 16 milliseconds is high enough so that for your eye all the digits appears to be lit all the times. Appears to be lit all the times. This is the logic behind the multiplexed display. Okay. Here in fact at any time we are going to select only one display only, but the refresh rate is so fast that, which is 16 milliseconds, means 40 times in a second we are going to refresh this. So, this is so high that for our eye we cannot interpret that change. For our eye it seems to be all the displays are lit all the times. So, this is the idea behind multiplexed display. Okay. So, now how to display this 1 to 8, what is the program required to display 1 to 8 on 8 7 segment displays? I will discuss the program. Suppose if I want to display this one for some time, and if I want to rotate this 1 here, 2 here, so like that we can extend this program to a rolling display. You might have seen at many places there will be some rolling display. There are some advertisements which are going to be rolled with some rate. Okay. So, you can extend this same logic to design a rolling display also. Okay. Now, first I will write the program to display 1 to 8 on the 8 7 segment displays, following the procedure that I have explained. So, initially you have to program the port A and port B as output ports, because you are using 2 ports. One port, port A, is used to apply the signal to the base of all the transistors, which drives common point of all the displays, and second port, port B, we are going to use to apply BCD signal to the BCD to 7 segment decoder. Okay. So, for that we need 2 ports to be programmed as output ports. So, in order to program all the ports as output ports in mode 0, we have derived the control word as ATH, move AL comma ATH out, control word register address is FFH, then AL. So, this instruction will clear or will program all the ports as output ports in mode 0. Okay. Now, what is the next step? You have to select the last display, and you have to display a 0 on this. Okay. So, for that this is connected to this common point is connected to PS0, okay, through this PNP transistor. So, in order to on this PNP transistor and apply a 5 volts to the common signal, so you have to send a 0 on base of this. If I send a 0 here, this will be 5 volts, thereby this will be selected. So, you send a 0 on this one, at the remaining displays you send a 1. so that the remaining displays will be disabled, this will be disabled, only this will be enabled. Then you send a code corresponding to 1 here, to display 1 here. Okay. So, you have to first send a 0 on PA0 and 1 on the remaining bits of the ports. So, PA7, PA6, PA5, PA4, PA3, PA2, PA1, PA0. You first send 1 1 1 1 1 1 1 0, which is equivalent to FE. So, you take this FE onto this one. Before that, I will initialize move DL with 0 1, because I want to display 1 on this particular display. That one I am taking, this is BCD code. If I apply this 1 to the BC to 7 segment decoder, it will display 1 on this display. So, I am taking this 0 1 into DL. Then I am taking move AL with FEH. So, I am storing this AL because all the times I have to use AL in out instructions. So, I am saving this FE content in move CL also. In CL I am storing this FE, because at the later stage I have to rotate this, because in the next stage I have to make this as 0, so that the second display will be selected, and so on. Okay. So, to do that I have taken this FEH into AL as well as CL also. Now, I can use AL for out instructions. Then out. So, because this is connected to port A, the address of the port A is FCH comma AL. Okay. With this instruction, so only this particular common pin of this display will be 5 volts, the remaining all display will be disabled. Then you have to send a 1 on this one. So, then you have to send 1 this BCD to 7 segment decoder, which is connected to port B, right. So, you take move AL comma DL out, port B is FDH comma AL. So, that 1 will be applied to this BC to 7 segment decoder. This is 7447. Here you are going to apply this 0 1, means last digits will be 0 0 0 1. Okay. So, that this will generate a code corresponding to 1. So, this will be BC will be 1 1. So, as a result of that, the display that is connected to here will display B and C, 1 will be displayed. Of course, these lines are common to all these 8 displays, but only the last display will be enabled, the remaining all display will be disabled. As a result of that, 1 will be displayed on the last display. Okay. Now, you call a delay. This delay will be of the order of 1 millisecond. Then before you are sending the second digit to second display, that is 2 to second display. So, you make sure that all the displays are off. Okay. So, I am going to off all the displays. How to off all the displays? So, you make move AL comma FF out port A FCH. So, with these 2 instructions, all the displays will be disabled. Initially you have enabled the last display, then after 1 millisecond you have disabled all the displays. Okay. This also you call for 1 more millisecond. We know how to write the delay programs, I am not discussing that here. Okay. Then, so you have to send 2, you have to display 2 on display 2. Okay. So, for that I am incrementing DL by 1, and before that, because I have to select the second display, the code corresponding to second display is this should be 1 1 1 1 1 1 0 1. Okay. So for that I am rotating the contents of CL, rotate contents of CL or CL left. CL, in CL we have initially this FEH. Now if I rotate by 1 bit, this CL contains now, so this is FDH. Okay, this FDH code is correspond to selection of the second display. Okay. Then you have to increment DL, because I have to display 2 on that particular display, INC DL. Totally how many digits we have to display is 8. Okay. So we have to compare with 9. Yesterday also I have used this logic, compare DL comma 0 9. Jump not equal means up to 8, this not equal will be true, so it will go to up 1. Then it will display the 2 on the second display, because we have already selected the second display here. So where should be this up 1 now? Up 1 should be here, move the contents of AL to CL, then out this contents of AL on this will be up 1. So that in AL we have here, this is AL, FF is there, you take this as CL and you make this CL to AL. Okay. Same thing, but because you are changing this CL, so you have to take CL here and AL here. This is CL and this is CL, this is AL. Okay. In CL we have the code corresponding to FD, so which I am taking into AL, then I am going to output this. Okay. After that D becomes 2, 3, 4, so like that 8 will be displayed on 8th display, 1 on first display, 2 on second display, like that 8 will be displayed on 8th display. Okay. So after that this will be false, then you have to do unconditional jump to up to, so that I want to repeat the same process. Okay. So where should be this up to? Up to should be, again you have to take DL with 0 1, so that the last segment will be selected, and again you have to take FE to send logic 1 corresponding to this first display. So up to will be here. So you see the program, so which will continuously displays 1 to 8 on the 8 displays. Okay. For our eye it seems to be, it appears to be all the displays are lit all the times, because that rate is 16 milliseconds. Okay. So this is how we can interface 8 displays to the 8086 using only single 7447. Okay. Still there are some drawbacks of this multiplexer display also. One of the drawback is it will be burden on the CPU. It will causes burden on CPU. If CPU is performing some important task, then so after displaying the first digit, so before coming for the second digit, so if this CPU is busy with some other important task, then what happens is only the first display will be enabled all the times and the remaining all will be disabled. Okay. So this is actually, this is burden on CPU. So in order to avoid this, we can use directly IC. There is one IC called 8279, which is called display controller. So this using display controller, we can directly connect multiple displays to the 8086. Okay. So this is about the 7 segment display interface. Now we will discuss how to connect high power devices to the 8086. because the 8255 ports can carry. So, if we take the 8255 ports, this is say for example PA0, if I program this as the output port, it can source a current of the order of 1/10 of milliamp, means 0.1 milliamp, of the order of 0.1 milliamps. Source means whenever this is high, this is going to source. And if I connect say PB0 as input port, so this can sink, this is 0, this can sink, this will be source through 5 volts of the supply. This can sink of the order of 4 milliamps to ground. But this much small currents may not be enough to drive high power devices, such as, what are the high power devices? Such as electric bulb, or you can have some sort of the coils, solenoids, motors, you can have heaters also even, because the microprocessor will be used in many of the industrial applications. So, where we need to control these high power devices such as electric bulbs, coils, solenoids, motors, heaters. Okay. If I take 8255 alone, the current capacity of this one is, the sink and source capacities are of the order of milliamps. Okay. So, these milliamps currents are not enough to drive high power devices. See? So, in order to drive these high power devices, we need some sort of the buffers. Buffers is nothing but current amplifiers. Okay. If I take a simple buffer, there are two ICs, IC buffer 7406 and 7407. This is non-inverted buffer, whereas this is inverted buffer. The symbol for this non-inverted buffer is this. If you have logic 0 here, output also logic 0 only. If you have logic 1 here, output is also logic 1. So, in terms of the voltage is same, but this is going to amplify the current. This will act as current amplifier. Whereas in case of inverting type buffer, logic 0 means logic 1, logic 1 means logic 0, but the current capacity will be more. This will also act as current amplifier. So, these are called IC buffers, integrated circuit buffers. So, this is 7406 IC, inside this we have 6 such inverters. So, inside this also will be having 6 such buffers. Okay. So, this current amplifier, by using these current amplifiers you can get the currents of the order of 40 milliamps also. This you can drive a little bit moderately high power devices. Okay. So, if you want still more currents, okay, so we have to go for transistor buffers. Okay. These are IC buffers and we have some transistor buffers also. So, we can construct the transistor buffer using either PNP transistor or NPN transistor. Okay. So, if I use this NPN transistor, the circuitry will be something like this. We have to give from port, this is ground, and here we have to connect replace 5 volts. So, you have to connect 150 ohms. and this will be 8.7 kilo ohms. This is from output port. This you can connect to the LED, or even you can connect here electric bulb also. This is connected to plus 5 volts. Now the advantage of this setup is, this is using NPN transistor. If it is PNP also, similar type of configuration will be there, only the resistor values will be different, and the connections are somewhat different. Collector is connected to plus 5 volts, emitter is connected to LED, this is 150 ohms, this is also from output port. This resistor value will be 2.7 kilo ohms. So here also this will be acts as buffers, means if input is 0, output is also 0, if input is 1, output is also 1. Okay. But the thing is, here they are going to amplify the currents. Okay. So this current passed through this LED will be more, even LEDs can be replaced with the bulbs also. So in that case, accordingly you have to take these voltages. Bulb means we require the larger voltages. So the current capacity of this buffers is 40 milliamps, whereas here using this transistor buffers we can go up to the 400 milliamps currents. Okay. From this port we know that this is going to give only current of the order of 40 milliamps of, suppose if I take this one as 20 milliamps. This 40 milliamps will be after buffer. So here this will be of the order of 1/10 of the milliamps. So I am taking this as 20 milliamps. Okay. And if the beta of the transistor is say 50, this IB is base current, this is base current, this is base, collector, emitter. So if I take this base current as 20 milliamps, we know that collector current will be equal to beta times IB. So implies what is IB? IB will be IC by beta, which is 20 milliamps by 50. Which comes around 0.4 milliamps. This is IC is equal to directly because IB is given. So this is equal to 50 times 20 milliamps. So this will comes around 10 to the power of -3, which is equal to 1 amp. This is large enough to control moderately high power devices. Okay. This is how we can use these buffers to amplify the current, thereby to drive the moderately high power devices. Okay. If we want the further high currents, this actually depends upon the beta. If beta value is large, basically IC is also large. If beta is large, IC is also large. So now to increase the beta, instead of using a single transistor here, we can use a Darlington pair. Okay. So using that again you can increase the current capacity. Darlington pair buffer circuit. So the basic idea is, here I will introduce all these things and I will discuss how to connect the motor, stepper motor, which is one of the important device which will be used in many applications. So how to connect stepper motor to the 8086. Okay. So using the Darlington pair we can increase the current capacity because beta will be more. In order to increase the beta, so instead of connecting a single transistor, I am going to connect 2 transistors. So, in the manner this we will take from port this I will connect to the emitter, I will connect to the base of the other transistor. This will be connected to the ground. So, I am not discussing about the designs, I will directly take the values of these resistors. So, this can be either solenoid or coil, relay or solenoid. So, depends upon the relay, the voltage that required for the relay, we will choose this V. That is why I have written this as V. This may not be 5 volts, you can actually take the more value also. Okay. This you have take from output port of 8255. So, using this configuration, this is called Darlington configuration. So, we can obtain the beta value of 1000, thereby the current capacity is also more. Okay. Now, if you want to further increase the beta value and if you want the higher currents, we can go for MOSFET circuits. So, using this beta value it can go up to some 4 amps. So, the MOSFET circuit will be, we will get from this output port to the gate of MOSFET. This will be plus V, this is motor winding which will require more currents. This will be from 8255 output port. This is MOSFET, power MOSFET. And also you can construct the same using IGBT, isolated gate bipolar transistor, isolated gate bipolar transistor. Is called IGBT, IGBT buffer circuit. This you have take from the output port of 8255. Normally this is similar to the transistor only, but here the gate will be isolated. So, this volts depends upon the capacity of this motor winding. Okay. Here also we are going to connect this to motor winding to the wide. Here also we are going to connect the motor winding. This is from 8255 output port. So, using these two configuration, we can obtain the output currents of the order of 400 amps. Now here you can go up to the 400 amperes. So which will be enough to drive the motors. You can use DC motor or stepper motor. Okay. Even if I want the further increase in these currents, such as heater requires very high current. Okay. For that we can use another circuit using triac based circuits. So in this circuit, so you have to take this again same from 8255 port. You have to connect to base of the transistor. This you have to ground. This will be connected to plus V, depends upon the voltage that is required for the load, 150 ohms. You have to connect to the LED. This will emit the light, and we require 3 circuits called, one is photo transistor. I am not drawing the entire circuit, just I am noting as block A, block B, block C. So these 3 are connected in cascade. So this C is going to control the triac, actual triac. This is symbol of triac. This triac will be connected to the load. So this voltage here will be high voltage, the order of 120 volts AC, alternating current, and the load here will be heater. This will act as a load heater. So this is, you can take this one as a block inside. So there is some sort of isolation here. This side is high voltage or high current circuit. This side is microprocessor, which operates with only 5 volts. Okay. If you do not have the proper isolation here, what happens is this high voltage sometimes may burn the ICs that are present this side. Okay. So because of that we have to provide the isolation. There is no physical contact, you can observe that. So this is this transistor part from here to here is, this is connected to the microprocessor, and this part is connected to the high power device. There is no connection here at all here. Okay. Now how the coupling will be takes place here? Through this LED. Okay. This LED, whenever if I apply, this is from output port of 8255. So whenever this LED glows, then what happens is, this is A will act as photo transistor. B is zero crossing detector. And C is actually this triggering circuit. So this, whenever this LED is on, this is going to emit the light. That light will be converted into current by using this photo transistor. That current will be processed through zero crossing detector, so that it will convert into unipolar. Then this will be given to the triggering circuit, which will trigger the triac. This is triac. So, this triac will act as on off switch thereby. So, it will allow this 120 volts to connect to this heater, okay, through this switch. So, this control circuit required 100 ohms and 0.1 microfarads. Okay. So, see how we can drive this current of this one is very large. So, we can have up to even 1000 amperes also. So, it depends upon the capacity of the heater that we are going to use here. We can design this circuitry to give that much current. So, as the current value increases, the demand of this load is more. We are going to incorporate one of these circuits. So, we started with simple IC buffer, the current capacity is somewhat less. Then to increase that, we went to the transistor buffer. Then using single transistor, the current capacity is still low. So, we used 2 combined transistor Darlington pair. To further improve the current, we went to the MOSFET and IGBT. To further improve the current, we can use the triac. So, these are the various circuits which will produce more currents, thereby you can drive the high power devices. Okay. So, with this background, we can interface a stepper motor to the microprocessor. Stepper motor finds lot of applications. In printers, mostly stepper motors will be used. So, stepper motor, as the name implies, is unlike continuous time motors which rotates continuously. Stepper motor rotate in steps. Okay. That type of step movement is required in many applications such as printer, where the paper will be moves step by step. Okay. So, in that case we have to use stepper motor. Okay. So, how to connect the stepper motor to the 8086? So, how to drive that stepper motor? For that we require this circuitry. So, interfacing of the stepper motor we will discuss in the next class. Thank you.